Okay, so what we want to look at today, one of the things we want to look at today is how do we measure these angles that we're looking at? You've all seen this little tool, and probably a lot better than what I'm drawing it. This, of course, is called a protractor. Very good. A protractor usually has a spot down here that's marked as its vertex that it extends over to each side. On some protractors, this is just the bottom edge. Others have it up from the bottom edge a little bit. That's usually marked at 0 degrees. Of course, up at the top here, this is 90 degrees. So this might be labeled 10, 20, 30, 40, 50, 60, 70, 80, and then 90. But along with those numbers, there might also be numbers that look like this. 170, 160, 150, 140, 130, 120, 110, 100. Looking at those numbers, how do you know which set of numbers to use? Well, let's look at how we use the protractor to measure an angle. And I'm sure you guys have done this before, so we're going to go through it pretty quickly. But when you have your angle, you want to line up one side with the 0 and the vertex of the angle at that little crosshair. So for this angle, is that about 160 or is that about 120? Or is that about 60 or about 120? 60. How do you know? It's acute. It's smaller than 90 degrees. You know that 90 degrees is a right angle or a square corner. That little square indicates it's a square corner. An acute angle is smaller than 90 degrees. If it's larger than 90 degrees, it's called obtuse. And I always think of it as acute things are usually small, and obtuse, you kind of think of obese being large. So this angle here is that the 30 or the 150? That one's 150 because it's obtuse, so it has to be numbers larger than 90. Do I need to go over any more of the protractor? You guys know how to use them. Do you guys have one of your drafting kits anymore? You do still get them in your drafting kits? No? Multiple triangles? Okay. Okay. Well, if you need to adjust up to, if you need to go over 90, all you have to do is this. Let's say you're asked to measure this angle here, and your triangle only goes up to 90 degrees. All you do is just take your straight edge and extend this line out and measure this angle. How would you get this one from that? Yeah, let's say this measures to be 43 degrees. This would be 180 minus 43. What's it called when two angles add up to 180 degrees? Supplements, supplementary. Of course, the other special case is when you have two angles that add up to a right angle or a square corner. Those are called what? Complementary. Now, like I've said before, these are, if you're anything like me, I could remember the words, but I had a hard time when I first saw them remembering which one's which. So I always remembered right angles 90 degrees, you get complements when you are right. So complementary and right angles go together. So we have these different types of angles. Let's use them, apply them to some lines. So if I tell you that this angle here is 36 degrees, What's this angle here have to be? Yeah, 180 minus 36 gives us 144 degrees. Those form, since this is a straight line across here, those two have to add up to 180 because they form a straight line. What would this angle here have to be? 36 again. There's two reasons there. Because this is a straight line, those two angles have to add up to 180 because they make a straight line. Or there's also that term, what do we call those two angles that are across from each other on intersecting lines? Vertical angles. A triangle adds up to how many degrees? Angle sum is 180. Very good. So if I tell you that this angle here is 57 degrees and that this angle here is 68 degrees, what's this angle up here have to be? 55? Okay, let's do it. 68 and 57 add up to 125. And 180 minus 125 is 55 degrees. So that is a 55 degree angle. Perfect. If we classify a triangle, what would I call this triangle here? A right triangle. Why is it a right triangle? Because it has a right angle. More importantly, the largest angle is a right angle, right? This would also be what type of triangle? Not necessarily 30, 60, 90. Scalene. Scalene means all three sides are different lengths. I could have this, which would be called what? Isosceles right triangle. This triangle here is isosceles because two sides are the same. That's what the hash marks mean. Those one hash marks mean the single hash marks mean they're the same. The double is different because there's a different number of hash marks. But it's also acute because the largest angle in it is acute. This triangle here is isosceles obtuse. It's obtuse because the largest angle, this one here, is obtuse. How do you know it's isosceles? Okay, if these two angles are the same, their opposite sides have to be the same. Remember, one of the rules in triangles that we've brought up is the largest side is always opposite the biggest angle. And vice versa, the smallest side is opposite the smallest angle. So if two angles are the same, the opposite sides have to be the same. Or if two sides are the same, the opposite angles must be the same. Come on. How many different ways can we name this angle here off of this picture? I might call it angle 1, right? Because it's numbered 1. CBD would work. Could also do angle, I don't know why I put CBC. CBD. You could also do angle DBC. It would be equivalent to angle 4. ABE, those would be equivalent, but that wouldn't necessarily be referring to this angle. It'd be referring to this one over here, even though they are equivalent, it's still a different angle. That's really about the only way. You might refer to it as angle B, but there's 4 angle B's here, isn't there? So you'd want to be a little more specific than that. So assuming these two lines are parallel, if I give you this angle here is 51 degrees, can you tell me what this angle has to be? Well, this is a parallel lines cut by a transversal. What are the angles? Yeah, the angles are either the same or supplements, right? So you're right, 180 minus 51 is 129 degrees. Good job. If this angle here is given as 81 degrees, what's this angle here have to be? No. You know, this one here is 51 degrees, correct? What's this one here going to be? That's got to be 48 degrees, exactly. 180 minus 132 is 48 degrees. If that's 48 degrees, this here is 48 degrees, which makes this one 132. Very good. Okay. If I have an angle if I construct sides, other lines that are parallel to each of these sides, like this here, this line's parallel to this side up here. This is parallel to this side over here, right? If I tell you this original angle was 42 degrees, what angles can I form by doing parallel sides like that? Well, this one, of course, is going to have to be what? 42 degrees. Are there any other angles I could form by making sides that are parallel to this? This is parallel to that side, right? This is parallel to that side. Is this angle 42 degrees? No. If I extended it this way, this would be 42 degrees. This one has to be 138, the supplement. But those angles have to be related. They're going to either be equal or supplements. That's important in construction a lot because you end up moving out, pushing out a few feet or whatever. You're generally not changing both sides of the angle, usually just one. But when you move one side of the angle, it's going to end up either being the same angle or a supplement. Okay, it's about that time in the first hour. I'm going to give you guys some pages to work on out of the book. This is the big book, obviously, page 470. Excuse me. Exercise 20-6. Page 472 through 473. Exercise 20-7. Page 476 through 477. Exercise 21-3. And page 482 through 489, or 484, I should say. Exercise 21-4. I'm giving you quite a bit of time here. I'm giving you a full 15 minutes. But I realize it's a lot of pages, but you should be able to go through it pretty quickly. It's mostly vocabulary and identifying.